Hi guys, so today we'll be taking a question on wave equation. So before I proceed, welcome to concept mastering. So the question says the equation of a transverse wave on a rope of weight 0.25 Newton, so 0, length 130 centimeter is given by y bracket t comma y bracket x comma t close bracket equals to 10 sine pi open bracket 0.01x plus 2.00t, where y and x are in centimeter, and t is in seconds. Find the amplitude, the frequency, the wavelength, the velocity of the wave, the maximum transverse speed of a particle in a rope, the maximum kinetic energy per unit length of the strings. You now say take your g equals to 10 meters second. 10 meter second. 10 meter second. Let me repeat the question again. It says the equation of a transverse wave on a rope of weight 0.25 Newton, length 130 centimeter is given by y bracket x comma t close bracket equals to 10 sine pi open bracket 0.01x plus 2.00t close bracket, where your y and your x are centimeter and t is in second. Find the I, Roman figure 1, your amplitude, Roman figure 2, II, the frequency, Roman figure 3, your wavelength, Roman figure 4, the velocity of the wave, Roman figure 5, the maximum transverse speed of the particle in the rope, Roman figure 6, the maximum kinetic energy per unit length of the strings. Take your g equals to 10 meters per second. 10 meters per second. So now the very first thing we are going to do now is to write out the given equation we were given. This is what we were given. We were given our yx comma t is equals to 10 sine bracket 0.01x plus 2.00t close bracket. This is the equation we were given. Now the next thing we are going to do, we are going to make this pi to go inside this bracket. That means we are going to have our y, x comma t is equals to 10 sine pi will multiply this will give us 0.01x, 0.01 pi x plus 2.00 pi x exactly. When pi going inside the bracket, this is what we are going to have. This is actually 1. Now the next thing is we are going to compare it with a wave equation that looks like almost like it. Yes, compare with y equals to a sine 2 pi f minus 2 pi x all over lambda close bracket. Exactly, this is what we are comparing it with. Now the very first one, Roman figure 1, they show we should find the amplitude. Now in our given in the one we are equation we are comparing it with, our A represents our amplitude. And if we trace it back to the given equation we were given, the position where we find this A, if you trace it back to the given equation, you see that at that position we have 10 there. That means 10 is our amplitude. Very, very simple. Very, very simple. You are just comparing it. We have here is A. In our own the equation we're comparing it with, we have A here. And A represents our amplitude. Now if you compare it with the given equation, at that position where A is, we have 10 there. Therefore our amplitude A be equals to 10 centimeter, because this A and this 10, you can see it, you are just comparing it. And why is it in centimeter? They tell us our y and x, our y is not our x is in centimeter, so that's why we are leaving it in centimeter. If they didn't strictly put centimeter, we would have used meter, but they use centimeter, so that's why we're using we leave our answer in centimeter. Now the second question, on my figure 2, they say we should find the frequency or frequency f. And find the f frequency. Now you do the same. You don't simply compare this with this. Now if the one we are comparing, the equation we are comparing it, if you look at here, you notice that this way our frequency is, it's between 2 pi and t. Now if you compare it with the given equation, where do we have t or where do we have pi? It's actually this one here. You can see it. You have 2.00 pi t. That means your f should be around here. Your f is actually here. So you just compare the two. You compare this one with this. What we have, that means your 2 pi, the one you're comparing with the given equation, with this one here. You're comparing with, here is 2.00 pi t. Exactly. You just compare the two of them now. Now there are two things that is common. I just cancel out the ones that are common. We have 2 here, we have 2 here. 2 we cancel 2. We have pi, pi we cancel pi. We have t, we we cancel t. You can see. Then we are left with f is just equals to 1. Hence, that is our answer. Very simple. Very, very simple. We don't simply compare this with this. We compare this one with this. We have 2 pi ft is equals to 2.00 pi t. 2 cancel 2. Pi, we cancel pi. T, we cancel t. We are left with f and just 1. This whole thing here is, since we cancel everything, what is left here is just 1. So that means our f is equals to 1. Hence. So move to the next question. We want figure 3. The tool should find the wavelength. That is our lambda. Wavelength, we want figure 3. II. This is what we are finding. Now you simply compare. You also compare. Now in the one where the equation we are comparing it with, we have 2 pi x over all over lambda. 2 pi x all over lambda. I always told you, always ignore the sign in front of it. What the sign means there is just showing if the wave is going in the negative direction or the positive, but also ignore it. You don't have any business with that. You're simply just comparing it with the equation and the given equation. So now which one are you comparing it with? This way lambda is, that means you have 2 pi x. 2 pi x all over lambda. Which one looks like it? You have 2 pi x. If you compare it to this one, to the given equation, you see that this is where x is. You can see x is here, and you can see lambda here. So they are almost the same. So you just compare it with it. Will be equals to 0.01 pi x. Exactly. Remember, this is 2. This is just 2. It's not 8. Then to not look at this, so I just cancel. 2 cancel 2. So now, the next thing is we are going to cancel out things. We are going to cancel out things. 0.01 by x. So now, you have x here, we have x here. X, we cancel x. You can see? X, we cancel x. We have pi, pi, we cancel pi. So you are left with 2 all over lambda equals to 0.01. So I'm left with 2 all over lambda. C all over lambda equals to 0.01. So we are going to do cross and multiply here. That means our lambda, if you do cross and multiply, if you do cross and multiply, you have your 2 will be equals to 0.01 times lambda exactly. Therefore, your lambda will be 2 divided by 0.01. Your lambda will be 2 divided by 0.01. Therefore, your lambda will be, if you divide 2 by 0.01, you are going to have 200 centimeter. 200 centimeter. 200 centimeter. And that is our answer to the lambda. That is our answer to the lambda. What do we do here? We simply compare this with this. We now bring here x, we cancel x, pi, we cancel pi. We are left with 2 all over lambda is equals to 0.01. The next thing is we are going to do cross and multiply. This will multiply this. Why this will multiply the one lambda? This over 1, this should be over 1. Exactly. So 2 times 1 will give you 2. Lambda times 0.01 will give you 0.01 lambda. Therefore, our lambda will now, if you make lambda the subject of the formula, our lambda will be 2 divided by 0.01. If you divide 2 by 0.01, you have your lambda is equals to 200 centimeter. 200 centimeter. Now let's solve the next question. The next question is the velocity, the velocity of the wave. The velocity of the wave. The velocity of the wave. IV, Roman figure 4. Listen attentively. Listen now, listen. So we have our V. We have our V is equals to F times lambda. We are finding our velocity, and we know that our velocity is actually F times lambda. And in our previous example, the first question we already find our frequency and also find our lambda. That means our velocity will now give us our frequency. What we got there was 1. Was 1 times what do we got as our lambda? We got 200 centimeter. 200 centimeter. If you multiply 2 of them, that means our velocity will now give us 200 centimeter per seconds. It's very easy. We are finding our velocity. We have already gotten our F and our lambda. Let me show you guys again. This is our F 1 inch and this is our lambda 2 centimeter. This is what we got. So if you put 1 here and put your 200 centimeter of the lambda, you're going to have 200 centimeter per seconds. So this is actually the answer to Roman figure IV, which is the velocity. Now, so should find the maximum transverse speed the maximum transverse speed of a particle in the rope. Listen very attentively. Listen very attentively. This is where it's getting serious now. This is kind of question you're going to see in your various exams. Roman figure 5. They say we should find the maximum transverse speed. Now the speed here is maximum. Now, what formula are we going to use this to find the maximum speed now? We are going to use our Vmax, which is the maximum speed, will be equals to our amplitude times our angular frequency f. Our angular frequency f. Now, exactly. So now, what is actually our A? Sorry, this is not it. No. You can use F to find it. Our maximum speed is equals to A times W. Your A there is your amplitude, and your W here is your angular frequency. Your angular frequency. Let me write it. Your A is amplitude. Your W is equals to angular frequency. Angular frequency. That is it. Now we have gotten our A is actually equals to, our A is actually 10 centimeter. Our A is 10 centimeter. Then our angular frequency. Our angular frequency is actually equals to 2 pi. That means our W is equals to 2 pi. Now listen very attentively. Listen. Wave equation, when it comes to wave equation, is all about understanding the question very well and comparing it with wave equations with other wave equations. Now, I want to show you guys something now. I want to show you guys. Listen attentively. We know that actually our V angular frequency is actually 2 pi f. 2 pi f. This is actually the formula for angular frequency. This is the formula, but we are using this. Why are we using this? Let me just write the equation for you guys again. We know that our y is equals to 10. The given equation we're given 10 sine 0.01 pi t plus 2 pi t. Yes. I wrote 2 pi t. It's actually 2.00 pi t. I just wrote 2. That's 0. There's nothing there. So I just wrote 2 pi t. Now, we are going to let's compare it with another wave equation, the standard wave equation. Y equals to a sine kx plus wt. Exactly. So in this question number 5, we are using this standard wave equation to compare it now. Now, if you notice something now, let's compare now. You notice, so if you compare this, that means our A, at this position A, you have 10 here. That means our K. What is K? K is actually 0.01 pi. 0.01 pi. How do we got our K? You see we have kx here, and this place we have 0.01 pi x. So that means our K is actually 0.01 pi. That's what it means. Now, what do we have as our omega? Our omega is actually 2 pi. If you compare it, we have omega here and we have t. If we compare it with the given equation we are given, you have 2 pi t. That means, what does it mean? It means that your omega is actually 2 pi. Exactly. This is why we are using Yeah, can you see? That's why we're using 2 pi in this second, in the equation we're about to solve. That's why we're using our omega is equals to 2 pi instead of omega equals to 2 pi f. No, we're going to use this, or omega is equals to 2 pi. I always tell you guys, this is angular frequency. When you're dealing with wave, your omega will be angular frequency, but if it is motion, circular motion, this omega will be angular velocity. Know this, know the difference. Know the difference. Now I proceed. We are still finding the maximum speed, the maximum transverse speed. So that means your Vmax, which is maximum speed, will be given A. What do you have as our A? Amplitude, you have 10 centimeter. You have 10. Our W, which is 2 pi times 2 pi. Exactly, 2 pi. That means our Vmax will be 20 times pi. And we all know that our pi is actually 22 times 7. So if you times 20 times 22 divided by 7, your Vmax will now give you 62.8 centimeter per seconds. This is the maximum transverse speed. This is the maximum transverse speed. And this is your final answer for Roman figure 5. Now, you may skip this step in when you're writing when you're writing exams, especially CBT exams. All these steps, you may just skip it. You just plug in your formula. Your Vmax is actually AW. Since you know your A and you know your omega, which is your angular frequency, actually 2 pi. Remember, I told you the reason why you're using 2 pi. You just plug in your formula and just go on with the next question. You don't have time to come and be comparing. No, I'm just giving the reason why we use 2 pi. Omega is actually 2 pi f, but we are using 2 pi. Why? Because we compared it. We have 2 pi t, and in the one we are comparing it, we have wt. That means your w is actually 2 pi. So that's why we are using actually 2 pi in our formula. So now we move to the last question. Which is the kinetic energy, the maximum kinetic energy per unit length of the strings. Listen very attentively. This is the most bulky question. Yeah, but no worry, I'm going to make it very simple for you guys. So Roman figure 6, the kinetic energy, this is what we are finding. Now, you know our kinetic energy formula, Ke is actually 1/2 mass times velocity squared. This is the formula for our kinetic energy if you are finding kinetic energy. But here, we don't want the total mass, because this formula is showing like if you are finding the total mass, you normally use this formula, but we don't want the total mass. What we want here is the mass per meter of the rope. That means we are going to use this. This is the formula we use now. That is, our Ke will be equals to 1/2 per meter. This is mass per meter, v squared, yes. When your u here, this thing means mass per meter. This means mass per meter. I told you why we are not using this formula. We are not using it. Why? Because if you are using this formula, you're only using it when you are finding the total mass. But in the question, they say you should find the maximum kinetic energy per unit mass. Sorry, the maximum kinetic energy, yes, per unit length. And what that length means mass per meter. That's what it means. You are finding the mass per meter in question number 6. Roman figure number 6. So that's why we're going to use this formula in particular. Now, we were given in the question, we are given this. Go back. We are given our weight. We are also given our length. So we are giving our weight, which is equals to 0.25 Newton. We were given our length in the equation, which is 130 centimeter. Convert it to meter is going to give you 1.3 meter. And we are given our G is equals to 10 meter per second. Yes, this is our G. Now, and I told you this guy that this is actually velocity. You guys know this is mass per meter. Now, for the mass per meter, this is the formula for it. Mass per meter is actually mass divided by your length. Exactly. The mass per meter is actually your mass divided by your length. Now, the very first thing is, let's find our mass. In this place, we are not giving our mass. So we're going to find our mass. And the formula for mass, if you want to find mass, your mass is equals to actually your weight divided by your G. If you want to find the formula, if you want to find the mass, is your weight divided by G. And therefore, our mass will now give us, what is our weight? We have 0.25 Newton. 0.25 Newton. What is our G? We have 10. So if you divide this by this, you're going to have 0.025 kg. Therefore, our mass, M, will be equals to 0.025 kg. 0.025 kg. So this is actually it. Yeah, you don't have our mass, so you have to let's get our mass. That's what you did there. Our mass is actually weight divided by your G. Your G is actually gravity. That will be equal to 0.25 divided by 10. That will give you 0.025 kg. Now, we are going to use this to find our mass per meter. Since we already have our mass and we already know our length, so we just plug in our formula to find our mass per meter. Now, our mass per meter will now give us to be equals to, what do we have as our mass? We have, what do we got there? We got 0.025 divided by, what's our length? We were given our length there. Our length there is 1.3. Yeah, 1.3. Let me show you guys. Look at it. We are finding mass and length now. We want to find the mass per meter. It's actually mass divided by length. This is our mass, 0.025 kg. You are finding our length. What is our length? Our length is given here, 1.3 meters. 1.3 meters. So that means our mass per unit length, our mass per unit meter, mass per meter will be equals to, divide this by this, you're going to have 0.019 kg per meter. Exactly, per meter. And you guys remember that our velocity, what we got our velocity initially, that means our V is actually 62.8 centimeter per second. The velocity we got in Roman figure, in question number, in Roman figure 4 rather, velocity of the speed, this is what we got. So we are going to change this to meter. If you change this to meter, what you are going to have, you're going to have your V is equals to 0.628 meter per second. You're going to divide this by 100. If you want to convert to meter, convert centimeter to meter, you simply divide it by 100. So you're going to have 0.628 meter per second. Exactly, meter per second. Now, since we have gotten all this, we're just going to plug in our parameters. Remember, I told you that this is the formula we're actually using. Kinetic energy equals to 1/2 mass per meter. This is mass per meter, then velocity squared. You have gotten this and you have known this. This is what we got as our mass per meter, and this is our velocity. So we just plug in our formula, plug in our, just substitute everything at once. Yes, that means our kinetic energy will give us 1/2. What's our mass per meter? 0.019 times 0.019 exactly, times, what do we have as our velocity? We have 0.628 meter per second. Exactly, 0.628. Remember, all squared. If you times this together, our kinetic energy will now give us 0.037 joule per meter. And this is your final answer. For the last question. Remember where we started here? From this question, we started here. We are using this formula. We first of all find our mass per meter. And this, we are giving this in our questions. If you go to the question, we are all giving all this. So our mass per meter is actually mass divided by a length. And what is our mass? We don't know mass yet, so you have to find our mass first. Our mass is actually weight divided by g, which is our gravity, actually due to gravity, which will be equals to 0.25 divided by 10. That means our mass is 0.025 kg. Now you put in our parameters there. This is our mass and this is our length. Divide your mass by your length, you get your mass per meter. You have gotten our velocity. You have our velocity in centimeter. We change it to meter, and this is what we're going to get. And the next thing is our kinetic energy. We just put in all what we have gotten, your mass per meter and your velocity. So this is going to be your final answer, 0.0037 joules per meter. Thank you very much for watching. Please subscribe, comment, and click on the like button. Thank you very much. Have a wonderful day.